go to the physiology of muscle pain. The root of the knot is a muscle contractor that does not unravel spontaneously. To solve this, we must release the flow of energy, relax the muscle fiber, undo the knot. Techniques such as massage, shiatsu, myofascial release, stretching are techniques that try to undo the knot using brute force, mechanical traction from the outside. Unlike these techniques, acupuncture undoes the knot using physics, again the power of the tips, having an inside effect. To understand the effect of needles, we need to understand the constitution of the muscle and the physiology of contraction. Muscle fiber is made up of muscle cells, called myocytes. Myocytes are elongated cells, and inside them, basically, we have organelles, one of which is the sarcoplasmic reticulum, where calcium ions with positive charge are stored. Protein fibers that interact with each other and cause muscle contraction, actin, myosin, and a liquid that bathes the interior of the cell. Muscle contraction occurs when a nervous stimulus occurs in the cell membrane, a stimulus that moves calcium ions from the sarcoplasmic reticulum to the sarcoplasm, where the ions bind to actin and promote contraction. The calcium ions, ionically bound to the actin fibers, cause them to slide over the myosin fibers, causing the cell to shorten. That is muscle contraction. So, muscle contraction is a chemical phenomenon. It's the free calcium ions in the sarcoplasm, the liquid inside the cell, with positive charge binding to actin sites that have negative electrical charge. The phenomenon of muscle contraction is basically physicochemical phenomenon, an ionic bonding chemical reaction. As calcium binds to actin, contraction occurs. With the end of the nervous stimulus, calcium ions return to the reticulum and the actin and myosin fibers relax, or they should. The bond between calcium and actin is a strong chemical bond due to the characteristic electronegativity of calcium. Some factors can cause the calcium ion to bind so strongly that the contraction does not cease even when the nervous stimulus ends. An amount of calcium ions that remain unduly bound and the volume of muscle fibers that are contracted will depend on biochemical factors present in the muscle, such as depletion of ATP, the fuel for maintaining cellular electrolytic balance, depletion of magnesium ion, accumulation of lactic acid, etc. This involuntary contraction that lasts longer than desired causes knots, cramp, and muscle pain in general. In order for us to make calcium ions detach from the actin and move back to the sarcoplasmic reticulum, we need to give them a stimulus. We do this through needles. Remember, calcium ions which have positive charge are very electronegative. This means that they are attracted to negative charges. To mobilize calcium ions away from actin, we need to provide a great negative charge than the actin fibers provide. In other words, attracting calcium ions with great force than the attraction to actin. When we insert needles into the ashi points, into the muscle knots, into the contractures, we are inserting into the group of myocytes an accumulation of negative ions, electrons, that occurs in the needle due to the power of the needle tip, of the tips. Sarcoplasm is a liquid rich in ions which promote electrostatic balance, mainly sodium and potassium ions. These ions form a conducting chain and make the sarcoplasm as a conductor for the electrochemical attraction between the needle tip and the calcium ions. When attracted out of the actin, they are promptly collected into the sarcoplasmic reticulum, where they are stored, putting an end on the contraction of the muscle fiber, the knot, and the pain. Thus, attracting calcium ions to their appropriate storage location, the needles resolve muscle pain from the inside. Now imagine two needles inserted in a muscle in a cramped situation, and we apply an electrical current between them to these needles. In addition to the accumulation of free electrons that the power of the tips causes to occur at the insertion point, we will have an even larger electron cloud at the points, as well as a cloud of electrons moving between the needles. The force of attraction that all this negative charge of the electronic fluid has on the positive calcium ions will attract them away from the actin, causing muscle relaxation. This is how we understand the physiology of muscle pain and contractures. How the excess negative charge produced locally by the needles attracts positive calcium ions, exerting a greater force of attraction than that exerted by the negatively charged sites present in actin fiber. This cloud of electrons accumulated at the tips of the needles causes muscles relaxation. We understood how needles relax muscles and solve pain.